All right, all right. How's everybody doing today? Week 2, eh? Anybody work on code this weekend? Hey, that's a few. All right, so as usual, we're going to start with questions. But before I do that, I did see, Patrick, you put out there that the solutions were not available. Yeah, sometimes that happens. I did it on my computer and then never saved it before I left, and I assumed they were open, so that's my apologies. Now, if that happens, we don't get a notification when you post in the channel. So if something like that happens or you want to contact me and get an answer to a question immediately, just message me because that'll go directly to my phone and I can open it up immediately then. But I didn't see that they were closed until I'm already here, and that doesn't do much good. So in the future, keep that in mind. Just contact me directly, message me on Slack, and it'll go right to our phones. All right. Do we have any questions on anything so far, or any of the problems from last week? Yes. Yep. One second. Let me just get it pulled up here. And I can't hear you. One sec.
The very last function.
So El Chifre?
Yeah. So you assign agent to the value of bond and then you reassign a value to bond.
Yep.
And the agent value also changes too.
It shouldn't. So I think the problem here, right? The problem here might be that bond at this point in time when El Chifre is run, this isn't the same bond value that was set all the way up here. That bond value could have been reset in any of these functions below or in any of the test cases. So I see in Dr. No that bond, oh, sorry, that's a local bond. I see that in JAWS, bond definitely gets reset to body double. I haven't looked at the order of the test cases, but it's very possible that JAWS runs and sets bond to body double. So at this point in time, agent gets whatever the current value of bond is, which might be body double. Then on 52, we completely reassign bond again to body double.
So when agent becomes, in JAWS, when agent becomes bond and bond becomes body double, why isn't that false? So JAWS isn't false. The way it runs is it's like taking out the ones that aren't assigned to the global bond. All of them are true except the last one, which is El Chifre. And so, and if you reverse JAWS and El Chifre, I spent time on this one. If you reverse them, the last one still needs to be false for the whole thing to be true. If that makes sense.
Okay, so I can't follow that all. So why don't we just step through this entire sequence then, if that's what we want to do?
Yeah, I guess I just want to know like why bond gets reassigned, why in JAWS bond gets assigned to agent to body double, but it doesn't, but agent still equals 007 as opposed to El Chifre, where, so isn't that like when you assign bond agent to bond within that function the first time, it doesn't change it, doesn't remove it from 007?
So instead of saying something wrong, let's just step through the whole thing then. Okay, so at the start, all the way at the top of this file, we've got bond in the global scope, and that's equal to 007. That's the only thing that's happened at this point. Then we just have a bunch of function definitions. So if we come down to the test cases and they run from top to bottom, just like the rest of our program, we see that we're going to run this test case first. And inside of this test case, it's going to call odd job, and it's going to save whatever odd job returns as the return value. So let's go up to odd job and see what's going on there. So over here, it's saying let agent in scope be equal to the result of the comparison between bond and 007. Now, this will keep track of everything that we've done. Bond is currently 007, so agent in scope is true, and this would be, we would have to predict true, right? So nothing has changed on our scope yet. So if we put true in there, we would expect that test case to pass. So then let's go down to the next one, and in here we're going to invoke Goldfinger. So we come back up here, and we're going to say, hey, is bond still equal to 007? And because we haven't updated anything, that should be true. Oh, just kidding, sorry. This Goldfinger gets called with a new bond. And we're going to evaluate whether that bond is equal to 007. So we've got Goldfinger here. And bond is currently undefined. We haven't invoked it with anything yet, so let's see what they invoked it with. Okay, so over here it looks like we're not calling Goldfinger with any argument. So what is bond in here? If we don't call it with any argument, what is it? Undefined, right? So that gets set now that we invoked it with no arguments. It's definitely going to stay undefined. Undefined is not equal to 007, so we would predict false, right?
Yes.
Cool. Okay, so now we're done with Goldfinger, and it didn't change anything on our global scope. So now we're going to call the Scaramanga function. I have no clue how to pronounce these names, but Scaramanga takes in a target, and then it reassigns target to be equal to whatever bond is, which at this point, it doesn't matter what we call target with. Target is going to become bond, which at this point in time is equal to 007, right? And so is the answer here true? Correct. Okay, so now we're going on, same thing, we're going to call Dr. No. We still haven't changed anything on the global scope. Dr. No is going to do what? Exactly. And now we want to know, is bond equal to 007? Is it? Correct. So we continue then to JAWS, and I guess only these final two actually did tricky things with the global scope. So JAWS gets invoked in this test case, and anything that JAWS does to the scope will be present when we come down to the next test case on El Chifre. So we go back up to JAWS, and JAWS takes a parameter called agent. Can somebody tell me what JAWS is invoked with in that test case? Nothing. So agent is undefined, right? So agent was nothing. Then over here we're saying agent is now equal to whatever bond is. And bond on my global scope is still 007. So agent is 007. Then we reassign. We don't have a bond inside of JAWS. So when we try to access this variable, we're going to actually modify the one that's on the global scope. And now this isn't a feature in old text editors, but in CodePen, this gold color on bond is telling you that that's a bond that's on the global scope. So bond in here becomes body double. So then on 43, it's saying, is agent equal to 007? So agent got reassigned to 007, which bond used to be. So 007 is 007, and that one is true, right?
Yes.
Okay. So now we go to our final test case, and that's going to call El Chifre. El Chifre creates its own scope again, and it creates its own agent. JAWS is done. It's done and running. We cleared it off the call stack completely. So in here, agent is getting assigned to whatever bond currently is. This is the bond on the global scope. So agent is body double. Now does agent equal 007? So what did we expect to put in here? And did that work?
Yes. So I guess that answered my question because I think I was confused about the single equals. It means this is being assigned this value, but that value isn't necessarily being assigned. Like there's no equivalence actually happening.
Which line are you referring to?
Like agent becoming agent is being assigned to whatever bond it is.
So whatever bond currently evaluates to on line 51
Right.
will be the value that agent now evaluates to.
Right, but it's not like agent is also becoming bond.
So on 52, your question is if reassigning bond is going to reassign agent.
Yeah.
The answer there is no. So we evaluate primitive data types to a single value at the time that that operation is done.
Got it.
So we plug in 007 over here on bond. We don't actually point to the relationship of bond. And so this is, I'm going to make sure that I cover this a little bit today, but that is the topic that we will cover next Monday. And so it's this idea of pass by value and pass by reference. When we use primitive data types like strings, booleans, or numbers, we pass them by value, which means go look up whatever that variable currently evaluates to, and now give me the same value for this new piece of data. But changing one won't change the other after that time. Each of those variables points to a specific value. They don't point to a relationship. I don't know if that makes any sense yet, but you'll see a difference today when we go over arrays and objects,
Sorry, in that
which are passed by reference.
So pass by value basically means you're going to be assigned this value, but that doesn't mean that that's going to hold if we're assigning.
So on 51, whatever value we give to agent, agent is going to hold that value until we ever reassign agent. It will never be affected by us reassigning bond, because each of these needs to be evaluated to a value, and then that value is what's stored at that point in time.
All right.
You can actually just put console logs to basically tell you what the variable value is.
Yeah, you could easily put a console log right before 51 that logs out bond and says agent will now be whatever this evaluates to.
So, you said it doesn't reassign the value?
For agent.
I'm sorry?
You said it doesn't reassign the value?
So on 52, when we reassign bond, that's not going to reassign what agent is set to. That's just going to give bond a new value. But agent was set to the value bond used to be, not what bond always is, if that makes sense.
And it used to be double
007, correct.
So it would still be 007, but agent would be 007 in 51, but in 52,
In 52, agent is not being touched at all.
Yeah.
and then
So-
in 54, agent would be
007. So over here, basically when we need to plug in this value of bond, and it's a primitive data type, it says, okay, go look up whatever bond is. Bond was 007, so we literally take 007, and the compiler doesn't care about that relationship anymore. It's the same here. We're saying agent is now equal to the value 007. And that's what's going to be interpreted and run. So the relationship there with bond, that value came from bond, the code doesn't care at all. So when we update bond, it's not going to touch agent. Agent was already evaluated to this specific value.
It's not like referring to a cell name in Excel or something like that.
Exactly. There's no reference. There's,
if we put let in front of
well, if we put let in front of bond, it's still not going to have any effect on agent. The only difference here is that bond wouldn't be reassigned to body double. This bond on the global scope would still be 007, and the let would mean that we create a new bond in here that's equal to body double. Now, I'll give you a visualization of the difference between pass by value and pass by reference right now when we go into a sample example. And we start covering these arrays and objects, which do work like how you're saying, Mike, where it's going to have a reference to the cell that that array actually lives on. And so any variable that's pointing to that same cell or space in memory will see changes that happen there. With primitive data types, that's not the case. It's whatever they evaluate to at that point in time. And then there's no relationship moving forward. Primitive data and complex data. So arrays, objects, and functions are complex, which means we can pass them by a reference, whereas primitive data types are evaluated at the line of operation to whatever variables those things currently evaluate to, whatever data value the other variables are holding. That's a good question. This is definitely a trickier one, especially with that global scope and how the test cases all share that global scope, and they will have side effects. So that was an example of a side effect where one of the later functions did change bond, and it wasn't so obvious until we literally stepped through every line of code that it ran. And that's the danger of the global scope. If you don't want that variable to be touched by multiple things, it shouldn't be on the global scope. Yes, which will give you an error if you actually try to change it, and so you protect it that way. Like if we made that bond constant, as soon as one of those other functions tries to touch the global bond, it will throw an error. Does that make sense? Okay, cool. So before we do a little bit of arrays, let's just make an example here. So over here, I'm creating two primitive data types, two variables that hold primitive data, and we're setting my age to 21, and then we're setting my num equal to whatever age is at that point in time. And then I'm logging out those original values over there. So what do we think will happen on lines 15 to 17? When I log them out again after line 15 has run.
My age will change, but my number will not.
Correct. I heard the answer over there. But so let's step through it. Over here we're saying make a space for my age, and that's equal to the value 21. On 10, we're saying my num is equal to whatever my age currently evaluates to. So the compiler pauses, it looks up my age on the scope, and it gets this value, 21. And it's going to plug in 21. It's not a copy, it's not a reference, it's literally just a piece of data that we evaluated to. And so the compiler first looks this up, and then basically plugs it in just like that. There's no relationship between those two. So then again with the console log, when we go to look those up on the scope, it first looks them up, and then it plugs in these values, and then it actually gives it to console log. So console log doesn't see those variables or a relationship. It sees what those variables evaluated to. Does that make sense? Then on 15, we're saying, hey, go to wherever my age is and reset its value completely to be 26. My num is unaffected here. My num has nothing to do with my age. We just set it to whatever my age used to be on 10. So 16 goes and looks up my age, which is now 26, and my num is still 21. And we can log those out again up there. Does that make sense? So with primitive data types, the global scope or the scope lists just hold a value. And that value has no relationship with anything else. It's just something that we evaluated at the point that they were assigned, which is on line 9, 10, and 15. Now that's a little bit different from how arrays are going to work. But to illustrate an example of arrays and usage, let's pretend that I've got this variable and it's a date. And this date is basically in the format that MySQL formats dates. And so this happens every day on my job and most other professional jobs, is that we get a date out of a database and we need to reformat this into a way that JavaScript will understand, or in a way that we can format it for humans to understand. So my goal here is that I want to create this output. Now arrays are ordered lists and they look something like this. So on line 9, I've created an array. I'm going to take advantage of the fact that arrays are numerically accessed and that they can be held in a certain order. So if anybody has any idea where I'm going with this, I basically want to take this number 3 and I want to get the corresponding month out of that array. And so here I'm just evaluating what that array is on line 10. That way it shows up as the last run line of code. And we see in the computer that it's stored like this. So now we don't usually cover this for a couple more lectures, but I don't want to teach you incorrectly and have to undo that. So if you don't follow all of this about the pass-by references, we're going to have a whole lecture on it. But basically, this bracket syntax is what signifies an array. It's what tells JavaScript, hey, I need to make a list, and it's basically the numbers mean something. And as soon as we have this constructor here, basically signified by that bracket, we tell JavaScript, hey, I'm creating a piece of data called myMonths, and myMonths is going to be a reference to this ordered list. And so actually that ordered list is stored a little bit differently in memory. It's going to be a byte address for where that data should actually exist. And I'm simplifying it a little bit here, but a memory address looks something like this. Or basically it goes out 8 digits to represent a byte. For our purposes, we're just going to call it 0x0 as the first spot in memory. And so in this first spot in memory is now where this constructor function is going to build this array. And I'm going to shorten it a bit here. But at this memory address, we've created this array. This is where the data actually lives in the computer. And on our scope list, that constructor is going to give us that memory address. So now when we want to look up myMonths, on the scope list we find, hey, it's actually where this piece of data is all the way over here at 0x0. And that means that later, if we change anything at memory address 0, any variable that points to address 0 will see those changes. That's the high level idea of what's going on here, is that complex data types are stored as a memory address. A variable points to a memory address. It's a reference to where that data actually lives. Where something like mynum evaluates directly to a number, and nobody else is going to change that. Only mynum holds its own value. So that's the difference between pass by reference and pass by value.
So if I went back to my Excel analogy,
Yeah.
I thought of that being the memory address is A1:D1. So
Exactly.
4 cells.
Exactly.
My months is a name I've given to the cell reference A1:D1.
Yep, and we can have multiple references to A1D1. So we're just going to do quick high levels of how to work with these arrays, and then we're going to wrap it up with the lecture so that you have some sort of reference to come back to. But basically, let's say that I want to log out the first month of this array. It's worth noting that programming has this weird tendency to start with 0 as the first index of anything. And you might be familiar with that with strings. If we log out the 0th index of a string, it gives us the first character as we know it, but it's really the 0th index. So, does anybody have any ideas on how I can log out January by accessing through myMonths? Rich?
myMonths, bracket element 1.
Exactly. So these brackets, just like we can access specific indexes of a string, these brackets are how we're going to, it's how we note to JavaScript, hey, I want to access a specific piece of data that's inside of something else. So what happens here is before we go to console log, it says, oh, I need to find my months. So we look on the global scope list, we see that it's pointing to this memory address, and we basically can plug this array in right where it says my months. Now it says specifically, I don't just want the whole thing, I want to go to the first index. And so this is 0, 1, 2, 3. And if we go to the first index, this is the value that we're going to get back. So, what happens here? If I say, hey, I need a piece of data that's called my first month, and it's equal to whatever is currently at the first index of my months. What do we think my first month evaluates to? So if we step through that process again, we know that the array reference and the first index evaluate to this string. This is a string. So do we think that my first month is a reference or a value? It's currently a piece of data that's a primitive data type. So over here, it's actually going to be that value specifically, that string. Do we have any ideas on how we can access this array and update a piece of data? Yep. How can we reassign?
Bracket 1, close bracket equals whatever.
Okay, so on line 15, I'm saying that I want to reassign something. And what I want to reassign is whatever is currently at the first index of my months. So we're going to follow this reference again. We're going to come to the first index, and then we can evaluate the right side. And the right side is December. So in here, we're going to put in December. We've just updated in memory whatever was at that current index. And in the future, anything that looks at this memory address and looks at 1 will actually see the string December. Do we think this changed anything to my first month?
Yeah. Oh, no, it didn't.
So we see if I log out my first month now here on 17, that it's equal to January. And that's because when we assigned it, it evaluated to this primitive data type, this string, January. My first month at this point has nothing else to do with my months anymore. It's not always pointing at this first index. It's pointing to, it's not pointing to anything anymore. It got set to whatever value was at that first index. But now we've just updated that first index for anybody that's still referencing that spot in memory. My first month isn't referencing that spot. It just took whatever used to be there. So if we log out my months, what do we expect to see? Exactly. So at a high level, this is how we reassign things inside of an array. And this is how we pull them out. And if we pull them out and it's a primitive data type, it won't have any relationship with the array after that point. We only use the array when we need to evaluate a value, and that's it. First month is saved as January, and later on, my months reflects the change, but my first month doesn't get updated. Mike.
So, okay, so primitive data doesn't update because, is it because like that is a memory address, so that's like I guess not static? Or,
Yes, in a sense, exactly. My months is always, for now, my months has been assigned to always point to whatever piece of data is at that memory address. These data types, though, they evaluate to a single value, so they just hold that value, and they don't have a relationship with anything else. Values get looked up at the time that we evaluate, and they're not references.
And then they're just gone from memory, just like.
Yeah, whenever we hit the bottom of this program, we clean up, and then everything is pretty much gone. Anything we can't access anymore. So when the program runs and we get to line 20, we can't access anything anymore, and that whiteboard would be completely erased.
Including
Yeah, including the memory. Basically, if we lose my months, JavaScript is smart enough to say, hey, you don't have anything that points over here anymore. So you have no way to get back here. So I'm also going to come over here and erase that. Rich.
Question, now if I stored that data, let's say in a function, in theory, if I call that function again, that data would be, life would come back to it, correct?
Yes. So if we had this inside of a function, anytime that function runs, it's going to create that space and set it to this. If we ran this program 2 months ago and a piece of that function changed my months, it doesn't matter. When we rerun the function, this line would still be in there and make a new array with those values.
Would it, if you only had, say, a piece of my months, I guess it still has to make the whole thing to even get a piece of it. So, I was saying if you only reference a piece of my months in a function.
Yeah,
But it would have to make the
It
whole
has
thing
to,
get a piece of it.
exactly. We have to put that array in memory somewhere for anything to reference it.
So it's able to just recreate. It's able to be like, oh, I remember what this was. Then like how does it know to recreate it? Like I guess if it's in a function, it's not technically gone. Like 'cause that's what I'm thinking of. It is like if you delete my months from global, but it exists in a function. Why would it still exist in a function? How would the function know?
Function doesn't get deleted, right? Unless you
Right,
delete
so
the
like,
function.
yeah, I guess like then if you delete from global, then is memory still exists then?
Okay, one more time. I've got it in a function now. What's the
Sorry.
question?
So if you put it in a function, but you delete it from global, even if it's still in that function, then it still exists in the memory.
It will exist in memory for as long as we're actually evaluating
evaluating
in
within that
between
function.
these brackets. So anytime I call create months, it's going to create a local functional scope. It's going to create this array. It's going to get a memory address. We're not doing any other work here. We hit these curly braces and we erase it off of memory. I could call create months,
Anytime you want,
yeah, over and over again.
put it on a loop.
And so here, every time we call create months, it's creating a new spot in memory with these values at those indexes. Then down here, it's going to change January to high. Then down here, it's going to delete everything. As soon as we call this again, it follows these instructions to do it again, exactly the same way. And anytime we hit the end of that function, it cleans up after itself.
This using var is change the way that you're deciding.
Okay, so
Oh no, I meant like the bottom where you have var my first month.
oh, down here, no, this changes nothing. And even in here, it changes nothing. The difference is JavaScript is still functionally scoped. So this my months only exists inside of that function. The one difference between var and let is that var is not block scoped. So if on the global scope, so functional scope, the same rules you know apply. This my months only exists inside of that function. Block scope, though, this wasn't a feature when we only had var. So anything that was run within a block still applied to its next highest level of a functional or global scope. So in this case, if true, it's always going to be true. We step into 14, we define my months. Because it's the var keyword, we're not putting it on the block scope, but we're putting it on this global scope. So down here, I can access my months and see that array. If I change this to let, my months does not exist on the global scope. We never told it make space on the global scope. So if this is tricky, it's just another reason why we shouldn't use var at all, and that was just bad habits, muscle memory. Don't use var anymore. Use let and const because it's a lot more predictable.
So when we did bar there, we defined it at the, not at both scopes, but at the global scope.
At the global scope, var keyword ignores block scope and it goes to its nearest scope, which in this case is the global. And if we run this, JavaScript is smart enough that it scans the whole file for var, let, and const ahead of time. And because it's a var, it did create my months and it did put it on the global scope to have space to be able to reference later on.
Is not assigning things like var, let, const like the same as assigning a var, basically?
Yeah, it'll automatically put it on the global scope. So in this case, it scans the whole program, it makes space for my months, but our code block never gets executed in here, so my months never gets a value. So it just stays undefined, just sitting right here, but we can still access that without an error because JavaScript saw the var keyword and knew that it meant something to us. If I go back to let over here, it was never told that my month should exist on the global scope because let says, hey, only make this exist inside of this block scope.
So we need a const.
Same thing, the same rules apply with const. Does that all make sense?
So then if false, it's not false and it never even made on months.
Exactly, but even if this was true, my months would only exist inside of here.
Oh, not if you can come on inside.
And as soon as we come out of there, my months is gone, it's deleted, so we can't access it from out here. If this is tripping you up, don't worry about var at all. Seriously, there's no reason that we need to use it ever again. Just let and const, and then all of the rules we've spoken about with functional block and global scope all apply. Make sense?
What else is in block scope aside from dependency?
So anything where you have two curly braces. So a for loop, if else, switch statement, which we haven't seen, while loop. Anything where you're opening up curly braces is a new block scope. And anything defined with let or const inside of those curly braces will only exist inside of those curly braces. Okay, cool.
Just to jump ahead a little bit, when you're defining a multi-array using curly braces, does that still apply?
The multi-dimensional array won't be made with curly braces. It will still be made with brackets. And so the outer brackets represent the whole grid.
I meant an object.
Okay, no, objects, no. The object is creating those things to exist inside of the object, but yes, those curlies don't count for these purposes, and we'll cover that in 2 days. Okay, so let's go back here and just mess with these arrays a little bit. Anybody want to get me started on a function that converts a database date into English? What do we think we want to do here? What are our steps? This will be the input that we take in. Can anybody tell me in English what we think we can do Yes, Rich.
I mean, the first thing I would do is let months and then define the months. And then I would split that string by the parameter db8.
Yep,
Split
yep.
it,
That's exactly where we're
three
headed,
months.
but that's code.
I guess like we'd slice it into 3 parts so that we define variables.
Okay, so yeah, in English we need to figure out original month, year, and date, right?
Split.
Yes, that's how we're going to do it. Before I go further, why am I seeing undefined right now? Because what? because I'm evaluating convert DB date, and convert DB date doesn't have a return keyword, so this function returns undefined. But what I did here is I set up the whole structure of my program. I set up an input, I set up the function, I called the function, and I checked the return value. And so right away, I know that this is kind of working as expected. I haven't done any work in here yet, but I'm able to access my function. I can pass in data. That's another thing I like to check immediately. So I see that I'm getting the correct data into my function. I'm able to call that function, and I've got my inputs and everything is set up. So I know I'm able to start doing some work. Now, yes, we said that we want to get the month, year, and the date out. And Rich mentioned a very helpful function called split. So what split does is it's operated on a string, and it takes in a delimiter. A delimiter is any string that you expect to appear within that original string, which in this case, we can pretty reliably give it a dash. And if we give it a dash, it's basically going to loop through that string, and anywhere it finds that delimiter, it's going to break it up and give us back an array. So it's the first time I'm using split, and we want to make sure that we're using it correctly. So we're going to call the argument with split and with this hyphen. I'm not going to guess at the whole problem. I'm going to go step by step and check every little thing I do. I call it active debugging. So over here, we're logging out what the split will do on that string. And I see that it gives us an array where this is basically the year, this is the month, and this is the date. So this is one thing I do with every function. I just need to get to the data I'm going to use and make sure I can access that data correctly. So we have the split there. We see that it works like how we want. And now with the console log as a reference, how can I access the year? It's what? Zeroth. So then that means the month is probably what? And then so immediately I want to check and make sure I did everything correctly before I'm trying to do any work on top of errors. Thank you. And we see here that I do get the year where I want the year, I do get the month, and I do get the day. Which means good. We found our data, we found the pieces we need, we're good to start doing work. Lastly, before we do more work, can anybody tell me why this is showing up before this over here, even though it looks like this happens first in my code? Exactly. So we can't do this console log until we evaluate every piece to a single value. So first it gets the converting, that's good. It gets my date, that's good. It gets 2, that's good. But over here, we don't have a value until we evaluate this entire function. So we're in the process of going through this function, and this will be the first thing that actually gets logged out because we're stepping through this code, and we do have values for all of these, and we're able to log that out first. Then that function spits out undefined. Undefined is right here. Now that console log has a value for each parameter, and that console log can run. Still with me? So, again, while architecting our problem, we can put in our sample output as a guide. I've got month, year, and day. What can I do to come back to this type of answer? How can I architect that? Rich.
I don't want to get complicated, but I would do month, I put all the months, and then within each month, I don't know if you need the days, you want to get that specific?
Not right now, but yes.
Okay,
Yes.
so then I would just have month, and I would list all the months.
Okay, so that's kind of what I've done up here, right? I've just shortened it for the purposes of this problem. But yeah, we know we've got a numeric month here. And I know that I can create an ordered list where that number means something to me. So how can I convert this 3 into this?
I have to be careful, right?
I'm sorry?
The 3 is it really a 3? Or is it a string?
It's a string.
You gotta name your months in that, right?
Yep, we've got an array with all of the month names, and we want to access this value. And like Mike said, that's a good question. Let's just see.
Why, this statement right?
So I just logged out what the type of that month is. And it's a string. But we need a number to be able to plug it in and get this value. But do we agree that I should take whatever this piece of data is, that string 03, and somehow get it into here to result in this value?
You gotta convert it to a number.
Yes.
So you gotta convert month to number, and then you have to do an if. This is equal to that in the array, then return that.
Yeah, well, that sounds like a test case, more so than something that needs to run every time of the function. But yeah, we need to convert that string into a number. Any ideas on how we can convert it?
Number,
Yep, so number like this would work.
month, inside number.
Like this.
I wouldn't use the brackets.
Okay, so
I would just
What-
dot number.
so what do you want to do here, Rich?
I don't know, right, but equals month name, dot number, parentheses, month.
Okay,
I don't know if you're allowed to do that.
so when we have the brackets here in JavaScript, and this is something we're going to cover more with objects, is that those brackets mean that we need to evaluate a term that's inside of there.
Okay.
In which case, yes, this string month put into the number function would become a number. And that number would be what's used to look up over here.
Okay.
Dot notation, and we're going to cover this in 2 days. Dot notation is something that's for objects. And to just give you a visual for what I mean, this is an object. And this object has a name. It has a name property. This is in 2 days, but basically these are a key and value pair. And so similar to an array, we can access a layer deeper inside that object. Line 32. What's wrong? Oh. So the result of line 38 is getting logged out right here. Basically, we were saying, hey, go find whatever this thing is, my person, which is an object, and we said access the name property on it. Or we said access whatever this evaluates to. And in that case, the string name evaluates to name. But the other way that we can access is like this. And so when we do it with the dot notation, there's no evaluation that goes on. It's literally going to be these characters. And we get the Chris there.
What's the benefit, what's good and what's bad about it?
So the benefit here is that I can plug a variable in to access a property. I might not know what the property is called. So in this case, we have a variable called property name, and it evaluates the string name. So over here, we must evaluate property name. It becomes the string name, and then we have something to actually look up on my person. So again, we're going to cover that in 2 days, but basically bracket notation is used to access pieces of data that you don't know. You can't hard code it, so it'll be a variable. And now we could write a function that maybe takes in a property name. And so any name we could take in and log out whatever property someone is trying to access without needing it to be inside our code. So that is a side tangent because you brought up dot notation.
Sorry.
So that's completely fine. So for arrays, and for today, all we care about is accessing data through brackets, and we have to access it with a number. There's no such thing as this. We can't put a number on dot notation.
But in bracket notation,
Exactly. So for today, we only care about the bracket notation. This is a sneak peek. So going back up here, we know that we've got this array, my months. And we know we have numeric indices that will match up with the months. And we know that we've got a string number over here. We need to convert that string number into a number and use that number as a key to access a piece of data inside of my months. So we know that month name is going to be accessing something on month names. And it needs to be a number for a month. So we covered one way that we could basically convert that string into a number, and it was using that explicit coercion of number in here. Does anybody have another idea on how we can convert a string to a number easily? I'm sorry? Yeah, and the two equal signs is going to be a comparison operator, which will give us true or false.
3 would be assigned.
Both of them, 2 and 3 don't assign, they just compare and return true or false. So I'll just show you shorthand is that if we have just one plus in front of a string, this is going to convert it into a number. And yeah, so it's stuff like that that we use way more often than explicit coercion ever.
Oh, is that like 0 plus month and then it converts the string to a number?
Exactly. So as a demo over here, let's say we have x equal to the string 10 plus x evaluates to the number 10.
So it's plus if you use minus or another operator, what would it make?
Use plus. I'm not sure what a single minus would do. Oops. Okay, the minus,
Okay.
yeah, that negates it. It makes it a negative version of itself. So over here, just to recap this real quick, we put some space in memory. X is equal to the string 10. Down here we said, what does plus x evaluate to? Plus x takes whatever x was and makes it a number, so we got 10. This doesn't change what x was because we're just evaluating a value on this line. Then down here we're looking at x again and we see x is still the string 10. No, none of these operations on a primitive data type will change the original thing. We need the assignment operator to rewrite that variable. So yeah, we've got month name here, and now because we're good active debuggers, we want to make sure that we did it correctly.
Would that be my month, not month?
Yeah.
Oh, no. Okay, I
I'm
see.
sorry.
I
Yep,
see.
you
I
are,
see, I see,
wait.
I see.
No, you're correct. I don't have anything called my month names. Where am I hitting? Oh. So we see here that the line on 28 logs out month name, which is March. So how can we, now we've got all our pieces. We needed a month name, we needed a year, we needed a date. How can I return this? What next? And there we go. We call that function and we see we get March 01, 2018. Now pretend that instead of wanting it like this, we wanted it like this. We want the first 3 letters of each month. But I don't want to update my months. What could I do? Any ideas here? I want the abbreviated month for each of these months. Okay, so where can that happen? Yeah, we should definitely slice. Where can we do that? Okay, where am I putting the dot? So right here? Yeah, we could go after the bracket here. What do I want to call slice with? So the end index is up until that final index. So we're saying, yeah, this is an order of operations problem. So we're just going to step through exactly what the compiler does. It needs to reduce this entire expression to a single value, and that single value is what we're going to put on month names. So we're going to start all the way from the left, and it's going to go look up my months, which is somewhere in memory over there, and that looks something like this. So we found that array and we plugged that in for my months. So now we can evaluate plus month. And now for this operator, we must first evaluate this piece of data, which is, so now we apply the plus to that and we get 3. Now we're calling the slice function on this, so this 3 gets plugged into the array and this whole thing evaluates to March. Now we can move forward to the right, and now we're calling slice on March, where the start index is 0 and the final index is 3. So we're saying, hey, start with this M and take me everything up until the 3rd index, or in other words, give me MAR. And so we evaluate to Mar, and that's what gets saved as month name, gets logged out down here, and gets placed down here. One sec. What was that, Mike?
Yeah, does it only work because is assigned to date pieces 1, but that happens to be number 3?
Well, it was a string 3. So over here, month evaluated to the string 3.
Right.
So when we look that up, we plug in that string 3. And now the plus is saying, hey, take whatever you just evaluated to and make it a number for me. This isn't going to go touch what month is currently assigned to. This is just saying for this one spot where we're operating, whatever I'm sitting next to, make it a number. And now that we've got our array and we've got a key, we can look at the index and evaluate this entire thing to the March string. And then we can proceed to the right. And if this returned a useful piece of data, we could continue. We could just keep going. I just chained another slice on here, and we see that Mar became AR. The point is just that as we evaluate one thing, it gets plugged in, and then we can continue going to the right as long as you want.
Because plus month is essentially a different value until you're converting month into that number.
Exactly.
You're saying like this is now a number, use that to refer to the array, but don't necessarily like mess with it. You can't mess with the array itself.
Not right now. We're not messing with the array. Yeah, Anna.
If you didn't put another month on Mar my months, could you do plus month on line 27?
So do I want to do +1?
Oh, minus.
Yeah, so I knew this trick was coming, so I just put a placeholder in there because I'm never going to get back 0 as a month. So I just put whatever in there. Probably null is a better choice. But yeah, over here, if we didn't have a placeholder in there, we have to know that, hey, the months that come out of the database are 1 base. They'll start at 1. And if my array starts at 0, I'm going to have to account for that discrepancy and decrement each month by 1. So what happens here is it's the same order of operations over here, except we now have an extra term. So first it looks up month, it plugs in 03, it converts that to a number, and now that we've got 2 terms on either side of this minus operator, we can evaluate that to 2. Index 2, and that will still work. So this is an example. We could set up our programs in any way that we want, as long as you know how the data is used and what the tricks are of those data types. There's no preference. If you want to account for the -1 or you want to do a placeholder, that's up to you.
Can you explain how
But because if you put slice with just one number, that'll just tell you where to start slicing it and then it goes to the end.
Exactly. So I'm just separating it out to two different lines here. Before whatever this resulted in, I then sliced again. But we know whatever this resulted in is month name, so I could just month name down there and call slice will have the same effect. And so now here to illustrate that, we see that we had MAR, and then we called slice on MAR with 1, which says, hey, start at the first index and go to the end. And so that's why that ended up with just AR. So any ideas on how I could make this function work so that the user could tell me if they want to shorten the month name, or it will still work if they don't want to shorten the month name? What can I do? We figured out all of the work we need to do. How do I make it reusable?
Like they can tell you if they want March or more.
Yeah.
So they,
What's a good way I could take maybe a switch from them? How can I know what they want?
you can have a parameter where they give you an argument.
Okay.
Now, I don't know how you define it, because it could be the number of characters they want, or I don't know how you want
Yeah, okay, let's just pretend that we're only doing abbreviated. 3 characters is all your only option. So you're just telling me if you want that or not.
false thing.
You would have to put an if statement to evaluate.
Exactly. So what can I say? We've now added an argument here for them to call this function if they want to evaluate it. And we're saying that that should be a true or falsy value. So to illustrate that, I'm now calling it with abbreviated as true. What should I do to handle this when abbreviated is true?
Do line 27 and return.
What's that?
You have to do line 27.
Yeah, what should I do?
If
Line 27 is going to be a full month name right now.
full month name, you have to do a slice.
Yeah, if abbreviated is
Slice
true,
0, comma 3.
then
Curly brackets, and then you have to slice month name in parentheses 0, comma 3.
Just like that.
That would give you MAR, or whatever you're looking for.
So where would it give me MAR? Is that going to be shown down here?
We need to make month name equal that.
Yeah, we have to reassign month name here. So originally, month name is going to be that string value. And down here, if it's abbreviated, we want to reassign month name to be the slice of the old month name. And then it will overwrite it, reassign it, and we'll get that logged out the same way with the abbreviation up here.
But if it's false, it'll give you the full.
If it's false, we're just going to skip this code block and get the full thing. And why would this not have done anything? Yeah, I mean, this line on 29 is going to evaluate to what we want, but we have to take that value and save it. It's not going to go update month name automatically. Does that make sense? And so should this work? What happens if I don't give it that parameter at all?
It's not evaluating the if.
Undefined.
Yeah, so what's happening down here if I don't give it anything?
Undefined is false.
Exactly. That all makes sense? Cool, let's get into how we use these things. Okay, what's an array? Somebody tell me, what's unique about arrays? What about the list? What's unique about that list? It's complex. It's numbered. That's the key thing about arrays, or that they're numbered and they have an order to them. How do we access pieces of that array? Bracket notation with what type of data?
Index of the element.
Which is a number. Now, line 4, what do we think the type of array is? Tricky question. It's JavaScript, so everything under the hood is implemented as an object. And if we log out type of array, it will say it's of type object. So instead, we get this really handy method to know if something's especially an array. So this is the array class. It's the implementation of array in JavaScript. That's why it's a capital A. That's a reserved word. We can't change it. But we'll get this function called isArray, where we can pass a piece of data to it, and it'll tell us true or false if that thing is an array or not. Type of we can't rely on to know if it's an array, because it could also be an object. It could also be a function. We don't know if it's definitely an array. So how do we access and how do we reassign? What's the trick? Brackets. Now the last thing is that arrays have this special dot length property. So we have some array, we can do dot length, and it's going to evaluate to how many elements are currently in that thing in memory. What do we think dot length of this would give us? 4. It'll give us 4. There are 4 elements inside of there. And so 4 is how many bigger than the max index? 1. So that's something to keep in the back of your heads. When we're going to loop through these things, we're probably going to use the length property, but the length property is 1 higher than the final index. And so that's something we're going to have to keep in mind, whether we want to do up to the length minus 1 or less than equal to the length, depending on what you start your index at. And then lastly, we're going to cover some basic methods on how to mutate these arrays and work with them. Any questions? Cool, so an array is a list-like data structure in JavaScript, and here we just have a few arrays. We've got an array of all numbers, we've got an array of strings, we've got an array of all sorts of different data types. It doesn't matter in JavaScript, which is awesome. Over here, what is this last value in the array going to be? The string of value. Now pretend on line 10, I say a variable is now equal to 100. What's in here? A value, exactly. Because at the time we construct this, we look up what this is, we get this value, and we plug that value in right there. If we change a variable later, this doesn't change. That was already evaluated. It's done. How would I be able to change this spot of the array? Exactly. I have to specifically access that index and say, hey, this spot of the array is now equal to this new value. Great. And the values inside of an array are called elements, and we access elements through an index. What is the type of an array? Yep, exactly. That's what it'll look like if you log it out in the console. What about here? What do we expect to get back? True. Yeah, this function returns true or false. If the thing is an array, it's true, else it's false. What happens if I just plug in the number 100 right here? False. Oh, exactly. Here's an example. So when we have an array, it's true. When we have a string, it's false. It's not an array.
So a string is not an array, but it's in.
But we can access the string similar to how we access an array. And the reason for that is because under the hood, strings are also coded as what? Objects. Yeah, I won't tell you that when you log out type of, but it is breaking them apart under the hood and saying 0 is equal to I, 1 is equal to space, etc.
I found out from the problem that strings aren't immutable. You can't edit directly.
Exactly, that's because they're passed by value. So if we did go and say string 2 is now equal to this, it wouldn't do anything because the original string variable was set to a specific value. So you have to fully reassign the string and build up the string that you want that variable to now be. Bracket access. So we access elements in an array the same way you'd access them in the string. We use brackets and we put in a numeric index number corresponding to the position inside the array. What is name 0? What is the type of name 0? Yep. 1, 2. What about 3? Exactly. However, unlike strings, we can directly access that index and we can change the element. What will happen if I log out names now? Yep, so on every line here we say, hey, go to names at 0. Names at 0 is completely reassigned to be Washington. And now anything that's still pointing at 0, I know these names are all wrong, but names is still at the 0th memory address. And anytime we go reference names, we'll see the changes we made to those indexes. So by the end, it's 0, 1, 2 as Washington, Adams, Jefferson. And when we log out names, which is pointing to the 0th memory address, that's what we'll see. So that's called a mutation. We mutated the array. We mutated the elements that existed there. So, remember earlier we said only complex types can be mutated. Why is that? What about primitive types means that they can't be mutated? They're passed by, so they're figured out at the time we evaluate something. They're not going to persist changes unless we keep an assignment operator there. So, changing the elements in an array is an example of mutating the value. We're going to the memory address. We're changing the thing. And anything else that points to that memory address will see those changes. So on line 7, we create an array called brace. On line 8, we create a string called brace. What am I going to put in up here for array on the global scope? Yeah, at this point in time, we have nothing in here. We go to the first spot of memory, which we're calling 0x0, and it's BRACE. So now on line 10, we go look up array. We see that it's memory address 0. We go to the 0th index, and we say, hey, you're reassigned now. You are G. What about with this string? Does anything happen? No, nothing. Like we go to string 0, but we can't actually change this here. It doesn't do anything.
Would it throw an error?
No, it won't throw an error. That line will probably still evaluate to the string G, but that data, that's not going to persist. We're not updating the scope because we haven't reassigned string. So if I log out this array, what do we see? Exactly. So, length property. Arrays, just like strings, have a length property. What will this length property put out? 3. So again, we touched on this a little bit before, but under the hood, the array is of type object, just like the string is. And so if we use dot notation, we can access a property that's been given to us by JavaScript. JavaScript has added this length property to any array you'll ever see, and it will automatically recalculate that length anytime we change the elements that are inside of it. So length, at the time it's evaluated, will always tell you how many elements are currently inside. And that's 3. You still with me here? We're moving fast. All right, cool. So now we're getting into some methods. Does anybody know what a method is? What's the difference between a method and a function?
Parentheses.
What's that?
It's like a verb.
Yeah, so it's semantics. A method is still a function, but a method is a special function that exists on an object. So the push method is a function that exists on every single array. It's called on a thing. That's why we have the dot notation here. It's just a special function rather than having function push that takes in an array and it takes in a value. This method automatically knows the array that it's operating on. It just needs a value. What do we think push does? Right up there in the green. Yep, exactly. So when we log out 8, we expect to see George, John, Thomas, and then James, because the push method will basically go, it'll add a comma, and it'll throw this value in here and add it to memory. Then also it says that the push method returns the new length of the array. So we can just save whatever names that push gave us into a variable over here, except without the spaces, you can't do that. And so that will be equal to 4. Honestly, that's pretty useless, because anytime we want to get the length, we'll just go look up the length at that point in time. So you won't usually save the result of names.push. They're using it as an example. Instead, I would just put names.push here, put in the value, and on another line I'd log out names.length, if that makes sense. Because if I had new length here and then I pushed over here, this doesn't mean anything to me anymore because that length would have been changed. But new length would be whatever the length was at this point in time. So I don't care what the push value returns. I just always want to look up the length when I want to look up the length. Does that make sense? Cool, so what's going to get logged out? Exactly. Did I see a hand? Yes, Rich.
This mutates or considered destructive from the original array.
Yes, so this is a mutable method. As soon as we call push, it's going to go look up names, it's going to follow it to the memory address, and it's going to go add a new value to it, whatever this is. And that's going to persist. Anybody that still looks at memory address 0 will see that change. There's no new array formed. We went to where it was in memory and we changed it. Anybody, any piece of data that's looking at that memory address will see these changes.
And that'll be that point on.
From that point on, as soon as that's executed, here, anything that comes after will see the updated data.
Why does that log out to just the length?
This one,
Yeah, why does new length log out the length?
the push method returns the new length.
Okay.
So they've just saved the result of calling the push method, but this is really useless. You won't use it too much. It's just safer to log out the length when you want it. Pop. Takes off the last element. So in the case that we had this array, we wanted to come pop something off. It's basically going to take this value, it's going to return this value to us, which is John, and it's going to totally delete it. And those changes will persist. And that length will be updated. But in this case, pop, it's taking a piece of data off. We want to know what it is sometimes. So pop is going to return to us what that piece, that element was that it popped off, which is a lot more usable than what push returns. So we can log out the popped value later on because it got evaluated. At this point in time, that value was John. And so I would just save John again as Jefferson. Sorry, it was Thomas. Just save Thomas again as Jefferson. Now when we log out names, we see names persisted that change. It only has George and John. Cool? So this one is a little bit different. This is called the shift method. And the shift basically pops off an element, does the same type of thing, but it's going to take them off from the front of the line, the front of that collection. So when we log out names, we've only got John and Thomas left, but like pop, shift returns what it popped off, which in this case was George. And we save that to Washington. So it's called shift because everything basically gets shifted over one to the left. Make sense? Unshift. Pretty similar to push, except it's actually going to unshift an element to the front of the array. And just like push, it gives us a useless return value in the new length of the array. So new length is now 4, but if we log out names, we see King George III is at the start of that array. Does that make sense? Cool. Index of. It's also an array method. It works similar to how strings work. We're going to give index of an element, and it's going to basically, under the hood, loop through this array, and if it finds an element that equals exactly the same element we gave it, it will return us that index. If it goes through the whole loop and it doesn't find it, it's going to return -1.
And if it finds more than one instance with the same value?
As soon as it finds the first value, it's going to return that index. So it's going to return the first one it finds, and it's not even going to look at the rest of the array. It has no clue if there are multiple values inside of there.
So it goes left to right.
It goes left to right, and as soon as we find George, we return 0. If George was over here, it doesn't matter. It's never going to get over here. Because under the hood, inside that 4, it has a return keyword. As soon as it finds it, it returns the current iterator. And so if we return, no matter how nested we are in a function, you're out of that function. It's done. It doesn't go through the rest. But if it doesn't find anything, we have another return keyword outside of the for loop, and that return keyword is going to give -1 because it'll only hit that bit of the code if it didn't find anything in the for loop. So that's something to consider. You're going to re-implement this method today, and you really have to think about how you use return keywords. A lot of times I see people say, hey, check if current element is equal to my target, return true, else return false. And that's inside of their for loop. So on the very first iteration, if this is not what we're looking for, they're returning false, and they're not looking at the rest of the array. So you have to think about when we're going to return and when you definitely have your answer. We can definitely return true as soon as we find the thing, but we can't return false unless we've checked everything. Still with me?
Almost like a scope.
Yeah, it's a scoping issue and learning how to think about your return and when it's going to happen. Very similar idea. The way we structure our program needs to match our logic. So, Slice, how do we think this one works? So what is my return value going to be here, Maggie?
John Thomas.
So the end index, what's special about the end index? End index is exclusive. So we're saying start at the first index, which is John, go up to the second index, but don't take it. So really we just want John. This didn't mutate the original array. It just evaluated to a new value. Names is unchanged.
So 1 gives an error.
1 will give us back an empty array. So what's going on here? This is the first immutable method that we've seen. Exactly. So we've got names. Names is at 0, 0. And then we say, hey, one term precedence is going to be equal to the result of calling slice. Under the hood, slice immediately starts by creating a new array. And it says, okay, I'm going to fill this array based on the numbers that they gave me. It says I'm going to go start at 1, which is John, go up until 2, so I'm not going to take anything there. I'm just going to take all those values I just went over. I'm going to put them, whatever they evaluated to, in this new array. Then at the end, I'm going to return this memory address to you. So one term precedence is now pointing at 0x1. So if I call names.push and I throw the last name Washington back into there, what's going to change over here if I call names.push? Which? Which is? Would we see any changes in one term precedence? Why? Where's one term precedence pointing? One term precedence isn't pointing to names.
Its own array.
Yeah, it's got its own array at this new memory address. All of that we're going to cover in its own lecture, but it's good to be aware of the differences between mutative methods and immutable methods. Slice is an immutable method. Any of its changes are going to be on a new array, and it's going to give you that new array.
So the first part of slice points to that index.
To the first index you want to start with, yep.
Okay, and then the comma in the second part, the second number is,
Is where you want to go up until.
so if I did, instead of 2, 3, and there is no 3,
Then we would get everything in the array.
everything from point 1 to point whatever.
Yeah,
So in that case, it would have been John Thomas.
exactly. So over here, because of slice's immutable nature, that means that if we call slice with no parameters, what does slice do?
Takes everything.
It takes everything. Is it going to give you the same array?
Copy.
It's going to give us a copy. It's just going to take, it's going to go to a new memory spot, and it's going to copy everybody down here. and give you a new version of that array that you can then work off of and mutate. And if we look back at memory address 0, it'll be the original one, unchanged. So slice is the easiest way to get a full copy of the array without touching the original. So remember that today when we have workshop problems that say they want you to do some immutable work and return a new array, you can start off right off the bat by slicing the first array they gave you, and now just touch that one and return that one. Don't manipulate the data they gave you.
So if you assign names to names copy,
So this is exactly where that lecture is going. But if we have names copy, and we said names copy is equal to names, we look names up on the global scope, and names is a reference. So names copy would also be a reference to the same spot in memory.
so both of them refer to the same array.
Exactly, which means now if we call names copy dot push, and we push in the string x, we come over to 0x0, we add this to that spot in memory, and now if we log out names, what would we see? Yeah, we're still looking at the same spot, 0x0, we come over here, that x is in there. Names doesn't know how it happened, but it happened.
So the only other way to copy the first array without using slice would be to iterate through it and there's no shovel method, right?
He was saying names.
Hold that thought.
Sorry, he was saying names, push, copy, names, copy.
I'm sorry? Yeah, so I want to, okay, right after we go through the final slides, we'll do an example of that, and remember your shovel, okay?
What if we don't put names copy? They let names copy.
So if on line 6 we just had names.slice,
Yeah.
well, this would still get evaluated. Names.slice would result in a new array with a new memory address, and then we go to the next line, we have no reference to it. We can never get back to what that was. JavaScript will just go delete it. It's a good question.
But that is the easiest way to copy or replicate.
I'll show you another way that's modern based on your shovel idea. But yes, before what I'm going to show you, slice is the easiest way to do it. No parameters, you don't have to think much, just call .slice. So what happens here? We've got names copied. They were equal to George, John, and Thomas. What happens when we do names copy 2 equals Paul?
Get rid of Thomas. Paul.
Okay, so it says go to whatever names copy is. It's memory address 0. Go to the second index and reassign it to Paul. Now we go to look up names copy again. It's still memory address 0. We go to memory address 0 and we push in Ringo. What happens now when I log out names?
Fine.
Names is unaffected.
What's that?
Right, names.
Names was unaffected by all the stuff you did to names copy. The way this is going.
Oh, sorry, you're correct. I did not draw that correctly. You are correct 100%, Mike. Names copy is a copy. I forgot that we were just going over an example of mutable.
I apologize.
Names copy is a separate spot in memory. That visualization is completely fucked. Names copy is its own array. And on that array, we added Paul and we pushed in Ringo. Names is unaffected. Names copy had the changes. I totally misread that one. Thank you for pointing it out. Does that make sense? Cool. Includes. This is similar to index of, but it's just going to return true or false. What does index of return? It returns the index the first time it finds the element. Includes just returns true or false if it also finds the same exact element or the same exact type of string here with those characters.
What's this? When they were in the video, they were saying that, I guess includes is more popular to use than index because there's a -1.
Yeah, so the thing with index of that makes it really tricky is we can't just coerce if array.index of. Because is -1 truthy or falsy? It's truthy. And what if we found the element at the 0th index?
False.
then that would be falsy. So instead, if we were using index of to coerce truthiness, and we wanted to say if the thing has an index inside of here, we have to check if the index of is equal to -1 or not.
Even though
Whereas includes is going to be a true or false. So we could just say, hey, if name includes, go look for it and log it out. Or whatever work we want to do. We don't have to think of that extra step of comparing the value and coercing it to a Boolean.
we probably have to use both because false is still
Well, name includes is directly going to return the Boolean value false, which would not activate that code block. You'd go to the else. The index of, we have to do an extra step to make sure we convert it to the type of Boolean we want. Yep. Reverse method. Reverse mutates. Key word there. It mutates the original array, reversing the order of its elements. So when I log out names, that array is going to have been changed in memory. And so reverse didn't return anything useful for us. We could just call it alone on this line because it's going to go change that thing in memory. I don't need to do anything with the return value there. Yes.
It's great for palindrome for strings, though.
Exactly. I know where you're going with that as well.
You can use that dot reverse on strings as well, and it'll provide you
Yep.
reverse.
Yep. So what Rich is saying is probably not the solution you want to do when we give you an is palindrome workshop, but he's saying the easiest thing to do is say, hey, if the original string is equal to the original string dot reverse,
Right.
I have a palindrome. That one's a little bit different though because the reverse on a string will not update the original string. It'll just evaluate on that line.
Right.
This array, wherever we call it, it's going to update that thing.
Unless I save it in memory.
What's that?
Unless I save that in memory.
Exactly.
What, say that again, sorry?
Which part? Reverse on a string isn't going to update everywhere that you have that variable. It's just going to evaluate to the reversed version of that string on that line.
What if you assign it to a different variable, like you let something equal string dot reverse?
Exactly. That's what you have to do. You can have let original string, let reverse string equal original string dot reverse. And the original string is still unaffected. With an array, that's not true. If we had let array equal 1, 2, 3 and let reversed array equal array dot reverse, both of them will now point to an array that's 3, 2, 1.
And you have to iterate through it, right? Because I know, like you do race car driver, because it ends in
Yep.
R and ends in
Yep.
R. Once you reverse it, it's not going to be the same, so you have to compare.
Yeah, well, under the hood, that's what reverse is doing, yeah.
So then things like includes and index of aren't technically mutable thing, right?
No, they're not
just
changing anything at all.
literally just check.
They're just letting you know if the
They're
thing
not
is there or
like-
where it is.
Right, but they're not like dot slice. Well, I guess they are because you could make a new thing out of like just checking, like, oh, I want to see what the index of this is and it equals this variable. You could build a new array using like index of.
Well, your index of could be a trigger for you to do some other code that's going to mutate, but index of itself is not going to affect anything.
Okay, you can't assign that to like a variable.
Yeah, but that would be on the next line. So let me just give you a new one and not overwrite this.
Can index of you use it for like prior to a test, like an if statement?
Exactly.
An if statement?
Or you can put it into a line which is slice.
Okay, so let's say we've got my array. It's equal to 1, 2, 3. And we want to know if my array dot index of, because it's a method on the array, so we call it on our array. If the index of 3, what does index of return?
That was the word, okay.
Okay, so how do I want to set up this condition in here then? Equals what? Okay, well in that case, that's because you know I've got the 3, but I think you're also thinking of 2 anyway, because that's the second numeric index.
It's not equal to -1.
Exactly, that's how we're going to use the index of, is if it's not equal to -1.
That'll iterate through the entire.
Under the hood it will, yeah. That's how index of will work. So now, he's saying that we know that the index is there. We could do something like this and reassign it. Exactly. So order of operations, and here again, before we can access anything in this array, we need to evaluate this entire expression to a number. And in this case, we first need to call this function. So it's going to look at my array, it's going to loop through it, it's going to find 3 at the second index, and it's going to plug 2 into here as the key. Now we can reassign what was at 2 to make it 4. So when I log out my array down here, those changes have persisted. Index of didn't do that. We used index of's return value to do that.
Could we also put if my array dot includes?
Exactly. And so this is what I would recommend just because it's less,
Right, yeah.
it's just less mental overhead to remember what index of returns and then code around it. Includes is very readable, it's straightforward, and includes is part of the new JavaScript ES6 syntax. Index of was the old way to do stuff like this.
So the index, excuse me, the include, we're actually looking at the actual element and not an index or an element per se. So
Yeah, I mean, it's going to loop through itself. It's going to access each piece of data there. It's going to save it as current element, and it's going to check, hey, is current element triple equals the argument that I received? If it is, return true.
True, okay.
Else, keep going. There probably isn't even an else.
So that would be a great search, better search feature than index of.
It's better. It's easier. It's more readable, and you don't have to deal with this -1 stuff.
Right, yeah. And then you just used index of later.
Yeah, I used index of there.
No, in other words, includes is the way to use it when you want to get true or false, and then index of is when you need it.
Yeah, if we have no clue where it is, we've got to use index of to find out where it is so we can directly access it.
But with it, yeah, but with includes, you technically wouldn't need index of 3 anymore, would you?
Well, in this case, we specifically wanted to go there and update.
Right.
So we are using index of, but maybe we just wanted to know if it includes something, and if it does, we're going to do something else with that array, or throw it out, or whatever.
Am I correct in thinking that index of is not that useful that often, just as it's only finding the first time it shows up, and it seems like most times you're finding something you would want to find everywhere.
Yeah, so that depends more on how you use your data structure, but I would probably use objects for something like this. And basically, if the object has a property on it, I know that that's the only thing there. And I would just structure it differently. If I needed to have multiple things there, I could set the value of that object to an array, and I can consistently throw stuff in there. So if I had an object where phone numbers are my properties, and I needed to know people who are associated with the number, I could set the phone number equal to an array, and in that array I could put everybody's name that lived at the house of the phone number. And so that's easier than doing it with this array. Again, we haven't covered objects yet, but we will. Okay, I think there are other couple great questions before we wrap this up. I'll cover the shovel in a second, but I think there was something else on the final slides. Any questions about arrays or how to use them? Okay, how do we loop through an array? Okay, for
Less than or equal to whatever the array is.
less than or less than equal to.
I use less than or equal to array -1.
Yes, so that completely depends on your personal preference. But again, I'm going to stress this point. As soon as we set up our loops, let's make sure we're accessing all of the data correctly. And what's more is it's really easy to go into bracket hell where we're typing these brackets all over the place. Let's just do it once and say that current is equal to my r at I. So now down here, I can log out current instead of worrying about doing this again. Great, so we set up our for loop, and now I made sure that I can access each piece of data. And I'm going to log out I as well, just to make sure that I am correctly going 0, 1, 2 all the way through. Right here, you're going to catch 80% of the bugs you're going to have when we deal with these types of logic. It always comes back to the for loop. And if I instead put 10 lines in here where I've assumed my for loop is correct, and I'm adding stuff together, I have no clue why I'm not getting the answer I wanted, because in my head, I've already assumed this is all good. So actively debug and test your assumptions. Okay, so what Rich was saying is that he prefers to do less than or equal to the length. which would mean what do we have to do? Exactly, and we test that, we see that that is also the same. How can I loop through this thing backwards?
Start
I is equal to what? And what is my condition now? Exactly, and we test that, we see that we got it. That was great. Okay, so the last question we had is slice. And if we wanted to copy, we slice with no parameters. And I could just get that in the green. We see that we get back a new array here. So if I have a comparison operator, how do we think we compare two arrays? Do we think these arrays are equal? Hold on, I'll move all this up. What do we think this is going to be? Exactly. This is the key difference between pass by value and pass by type, or pass by reference. When we create the original array, it's in here with 1, 2, 3. As soon as we create new array, we create a new spot in memory, and it will also hold 1, 2, and 3. But the value of that variable is pointing to a different spot in memory. So they're going to be false. That's correct. So what happens here? Still false. It's a new copy.
You have to iterate for each array to compare. I don't know if that.
Yep. So the comparator is just going to tell us if they're pointing to the same spot in memory. Maybe we do have two arrays and we know they're different spots in memory, but we want to know if they hold the same things. We're going to have to deeply examine it. Like you said, we're going to have to look at each element. And if any of the elements are different, we're going to log out false. And if there was another array inside of those elements, when we compare it, we're going to get the reference addresses to those and have to know. Question. Okay, so last thing I wanted to show you instead of the slice is that JavaScript gave us this new shorthand syntax to do basically the same thing as slice. And it's ... my array.
Does spaces make a difference on the left and right of that?
No, I'm doing that for readability. But basically, you don't have to know this. But if you do adopt it, I think it's easier. Basically, this is saying, hey, take whatever my array is, go to each of these, and spread them down into a new array. And then we get back, because that's a constructor here, we're constructing a new array, and we're saying just fill it with the values that's in my array. And so that's an easy way to get a copy. Which means that I can also do this. What will this look like? I'm sorry?
6 elements.
6 elements, exactly. So in this case, we had my array with 1, 2, 3. We created a new array, which was basically a copy of the values that was in there. And down here we're saying make another new array and spread the values from the first one and the second one. So that's super useful. Anybody have any idea what happens if I don't spread that second one?
That's a single element.
Yeah, and what is that single element? See the difference here? We still only have 4 elements. I mean, now we only have 4 elements, but the 4th element is that array. This is a reference to that memory address, wherever that is.
That's the whole array.
Yep. How can I access this entire array now? What?
New array
4?
3.
Okay, right. So this new array 3, evaluates to that array that was inside of there. And to illustrate my point, do we think that this array is equal to this array?
No.
Yes.
No, it changed. Oh no, yes.
You only have 3 elements.
Yep, we haven't changed anything. We just took this array and we made another reference to it over here. They're both pointing to the same spot. That's real tricky. That we're covering another day. I just wanted to illustrate that point. Lastly, oops. Now, because we know new array 2, accessing the third index evaluates to this, how can I access this element? Exactly. So we see here on the green, this evaluated to 2. Basically, it said go find new array 2, which this whole thing. Then it says go to the third index, which is this thing. And then it says go to the second element, which is that. And that evaluated, go to the first index, or second element, which is the numeric value of 2. So this is called basically a multi-dimensional array. It's when we've got an array inside of an array. And because of the order of operations we spoke about, we go left to right and evaluate each of these things. So as long as this thing evaluated to an array, we can go another level deeper, or another level deeper. And that is what we'll cover tomorrow with deeper arrays. Today is straightforward, as straightforward as you can be with this stuff. And that is more basic practice with the methods we covered today. Any questions?
So the console log you did there, that's to check to see that the array that you create that you're looping for.
And then your
Yeah.
computer is probably about to die.
Yeah, I see that. Oh, shit. Didn't see we're literally on 0. We're good. Thank you. Save the video. Whew. Okay. Yeah. So as soon as we set up a for loop, these can be very tricky, especially as beginners. So rather than just assume we did it correctly and do work that we don't know how it's working, I always advocate, I still do this today, I will log out that it does what I want. I always make sure I can access the data I want so that I know exactly where to do work. Like I'll look at the array and I'll say, okay, I need indexes 3 and 10, so I can pull them off. Same way we did it with the date before. We just wanted to split the date, check what it actually returns, and then we don't have to guess. We say we know the year is at 0, we know the month is at 1, we know the day is at 2. That makes it a lot easier to tackle it step by step and make sure you can access the data and pull those things off. So here, I don't want to think about this over and over and over again. I just want to pull off what this is and know it as current. And I can keep my code readable. So I can now say current plus counter or whatever, rather than say my RI plus the counter. That doesn't make sense. It's not readable. You don't have to do it that way, but it's going to save you a lot of time and effort.
Yeah, so when you're grabbing a particular element, assign it to a variable that's local to that loop.
Yep.
So that you can see within that loop that local variable is being manipulated. And
Yeah,
so
it just removes the headspace of needing to do this over and over. What if I'm doing 10 bits of work on the current element? I gotta type my array I over and over and over again. And sometimes you see people do stuff like this, and they think that that's the current element, but this is a new array where I is an element inside of it. And so it just eliminates those mistakes by only needing to figure it out once and log it out. Then you know you're good. You access the array, you loop through it, do what you need to do.
I know this is way above what you're saying, but if we had a function and you wanted to call how many columns and rows of a table you created using arrays,
Okay.
or just one number, and you would use a for loop to create those columns and rows through an array. I was working on architect. The issue that I had was if I wanted to populate, instead of having it as an empty array, to populate it with something.
Yeah.
Would I do that as I'm creating the arrays? Or do I do
So
it after?
in that case, and this doesn't apply if you kind of follow the question. It's tricky. We'll see it again with the Sudoku problem. But in the case that you're building up an array, I would probably say, hey, let new array equal an array. Then in here, based on whatever logic, I'll populate that array. And at the end, I'll push that array onto the main array, or I'll override an index and access it. But yeah, I'm going to avoid using bracket notation as much as possible. I'm just going to make my instructions very simple and clear. Just do one bit of work. And at the end, now go throw it in. I'm not going to throw the array in deep and then try to access that deep spot every single time, if that makes sense.
So that makes sense.
We'll cover that again. We good?
So that would be the shovel method, use the dot dot.
Yes, that's called the spread operator, and I'll link to that. It's just something to know in the back of your head if you ever want to return to it. JavaScript has become so much easier in the last 2 years because they give us these really nice, readable methods that are a lot less work for us to think about. You know, right now it looks like symbols, but soon looking at a spread makes a lot more sense than trying to process what this actually did. And to do something where we're spreading multiples in here would take me multiple lines of code before.
And there's no way to determine what elements you want from that array.
The spread will take everything.
Everything. All
Yeah. So instead, you could have maybe did a slice on here to slice between 2 and 5. And because this will evaluate first, you can then spread that.
Oh, that's nice.
Yep. All right, let's take a 5-minute break, get to workshop. I will link these out and the spread documentation.